This Introduction to Python series is part of the EPSCoR Track 2 DDMD workshop. This lecture is going to focus on Python operators. So why are we even learning to program in Python? Well, we have problems that we want to solve, and we've determined that leveraging computer power to solve these problems is the best bet. If you were asked to describe a computer, you might quite rightly describe it as maybe a desktop machine with a monitor and a keyboard and a box containing a bunch of electronics for processing and storage. Or you might describe it as a more portable laptop device, or perhaps a smartphone. And these are all different, these all represent computers. But I want to talk about it a little differently as a model of a computer. In order for a computer to process information, first we need some type of input into the process. And this input could come from a keyboard, a mouse, a microphone, touch screen. Then we need a processor, CPU, to actually take the input and process it in some manner to produce output. And then, of course, we need output devices such as output screen or a printer to present the new processed information to the user. And as this information is processed, we need some kind of a storage for storing the final results, or even storing intermittent results. And this storage could be what we call memory or RAM, and it can be more permanent storage, such as a hard drive or a flash drive. So we talked about a computer accepting input from an input device, processing the input, perhaps saving some information to storage, and eventually outputting information to the user. But how does a computer even know what to do? Well, that's where we come in. We're writing Python programs to give the computer instructions. So our Python program is going to inform the user what input is required, where the input is going to come from, how the input is going to be processed, how the processed information is going to be stored, and how and where the output is going to be displayed to the user. Let's take, for example, text messaging. You want to text a message to your friend. So you take out your smartphone. On your smartphone, you have a program. This program is your text messaging program. So you open up your text messaging program and you start typing in a text message to your user. So your input is your text message that you're typing on the keypad that is offered to you on your smartphone. As you type that in, the text messaging program is processing your text message. It's autocomplete, spell checker, whatever. And then once you press the send button, the text messaging program processes that text message and knows how to send it as output to your friend's smartphone. Programming languages allow programmers to develop software. And there's three major families of programming languages. There's machine language, assembly language, and high-level languages. All programs need to be translated into machine code so that a computer can understand the instructions. Machine code is ones and zeros, binary, and it's basically the only type of instructions that a computer processor can understand. So some programs are translated using a compiler, When a program is compiled, they're translated into machine code all at once. Some programs are translated into machine code using an interpreter. Such programs are translated line by line instead of all at once, like in a compiled program. Interpreted programs generally translate quicker than compiled programs, but have a slower execution speed. This workshop is focusing on the Python programming language. Python programming language was invented by Guido van Rossum in the early 1990s. Python is a high-level, general-purpose programming language for solving problems on modern computer systems. So our Anaconda Jupyter Notebook installation will run our Python commands with the native Python interpreter. As we develop our Python programs, we always want to think about it in terms of input, process, output. And we can look at it through 4 fundamental metaphors. Our Python program we can think of as a recipe, instructions for solving a specific problem. Input, as we receive input from the user, we're going to store that input in something we call variables, and we can think of that just as a container. Then we're going to process that input. In a lot of examples, we'll process that input and think about the central processing unit as a calculator. For example, maybe we're going to write a Python program that asks the user to enter 2 numbers. Maybe we're going to add those 2 numbers together. So in our Python program, we'll use it as a calculator to add 2 numbers. And then we need to worry about different data types. For example, if we ask the user to enter their name and age, we obviously can't add name and age together because they're different data types, and so that's like comparing apples and oranges. Understanding data types is a very important concept in Python programming. This diagram shows you the different data types that are going to be available to us as we develop our programs. Specifically, I want to look at numbers, Boolean, and string. The other data types we'll talk about later. But a string represents like a name. Carol is a string. University of South Dakota is a string. Numbers can be broken down into 2 different data types, floating point and integer. In Boolean, only can take on 2 values. Boolean is either true or it's false. Here's an example of subtracting 2 numbers that are integers. And here's an example of subtracting 2 numbers that are floating point. Data types are the classification or categorization of data items. It represents the kind of value that tells what operations can be performed on a particular data. Int and float are the numeric data types, and they both represent numbers. Scalar data types can hold 1 value at a time. An int represents an integer, a float represents a real number, and a bool is used to represent the Boolean values true and false. In real life, the range of integers is infinite, but because the computer's memory is limited, we need to limit the range of our Python integers. So a Python int, the typical range is -2 to the 31 to 2 to the 31 minus 1. And when you enter integers into the system, the literals are written without commas. Real numbers have infinite precision. The digits in the fractional part can continue forever. Python uses floating point numbers to represent real numbers. Python float typical range is -10 to the 308 to 10 to the 308, and the typical precision is 16 digits. A floating point number can be written using either ordinary decimal notation or scientific notation, and this table below presents examples of that. A string is a sequence of characters. A character is simply a symbol. For example, the English language has 26 characters, A through Z. In the following print statement, hello world is a string. In some instances, we can think of our Python program as a calculator. We have 7 operators that are available to us. We have the addition operator, the subtraction operator, the multiplication operator, and note that multiplication is represented by an asterisk. We have division, we have modulus, we have quotient, and we have exponent. So we're going to create a Jupyter notebook called Operators and Assignment Statements to test these operators. So you're going to want to launch your Jupyter notebook, navigate to your EPSCoR Python workshop folder, and create a new Python workbook called Operators and Assignment Statements. Operators are the symbols which tell the Python interpreter to do some mathematical or logical operations. Below I present a few basic examples of mathematical operators. In the statement print 2 plus 3, the operator plus, we're adding an integer plus an integer, so the result is an integer. In the second example, 23 minus 3, we're subtracting an integer from an integer, which results in an integer. 12 times 4, we have integer times an integer, which results in an integer. And in the last example, we have 22.0 divided by 12. So we have a float divided by an integer, which results in a float. Modular arithmetic is performed on integers. When we divide 2 integers, we will have an equation that looks like the following, where A is the dividend, B is the divisor, Q is the quotient, and R is the remainder. Sometimes we're interested in the remainder R. We would say that this is A modular B is equal to R, or A mod B equals R. And here we present some examples where we have 2 mod 3, which is equal to 2, 23 mod 3, which is equal to 2, 12 mod 4, which is equal to 0, and 12 mod 23, which is equal to 12. When we divide 2 integers, we will have an equation that looks like the following, again, where A is the dividend, B is the divisor, Q is the quotient, and R is the remainder. And sometimes we're interested in the quotient. So we could say A div B will give us the quotient. Here's some examples where we have 2 div 3, which is equal to 0, 23 div 3, which is equal to 7, 12 div 4, which is equal to 3, and 12 div 23, which is equal to 0. The exponent operator is represented by a double asterisk. In an exponent expression, the left operand is raised to the power of the right. So in this example, we have x raised to the power of y. And here are some examples where we have 10 to the power of 2, which is 100, 2 to the power of 10, 1024, 6 cubed, which is 216, and 4 to the power of 5, which was 1024. So we've talked about arithmetic operators. Now we're going to focus on relational operators. There's 6 relational operators: less than or equal to, greater than or equal to, and not equal to. It's important to remember that when these relational operators are applied, the result is a Boolean value. The result is either true or false. So here's some examples that you can test in your Jupyter workbook. So the expressions return true or false. So we could ask the question, is 10 less than 2? False. Is 10 less than or equal to 2? False. Is 10 greater than 2? True. Is 10 greater than or equal to 2? True. Is 10 equal to 2? False. And is 10 not equal to 2, which is true. And notice if you test these in your Jupyter notebook, the actual output is true or false, depending on the expression. It's important to note that to ask the question if 10 is equal to 2, notice that equal is a double equal sign. And notice that for not equal, we have an exclamation mark and an equal sign. In addition to our relational operators, we have Boolean operators. Our Boolean operators are and, or, and not. It's important to note that these Boolean operators only operate on Boolean values. Let's look at these examples to remind us how Boolean operators work. So if we take the AND operator, we have puppies and kittens. So we want the group that includes both puppies and kittens. Maybe we have a group of people that have a bunch of pets. And in this group of people, we want to say, okay, we want to get the list of people that own both puppies and kittens. Or maybe we have a group of people and we want to ask the question, who in this group has puppies and kittens? So you have either one. So you have a kitten, you have a puppy, maybe you have both. So that's going to give you a more inclusive group that includes everybody that has a puppy or a kitten as a pet. And then we want to look at the example, puppy but not kitten. So we want a group of all the people that have a puppy but they do not have a kitten. So and it has to be both. So it's true and true. Or is either one. So if either one of them is true, it's included. And not is one but not the other. So let's say we want to ask the question, is 10 greater than 2 and 15? So we could write the expression, we're just going to print it to the output. 10 greater than 2 and 10 is greater than 15. So let's see how this is evaluated. So the first thing that the processor does is it evaluates 10 greater than 2, and that's true. Then it evaluates the expression 10 greater than 15, which is false. So we have 10 greater than 2 is true, 10 greater than 15 is false. Now our Boolean operator AND can operate on the Boolean value true and false. Well, with the AND operator, both of them have to be true in order for the results to be true. But true and false is false. So in this example, we're combining arithmetic operators, relational operators, and Boolean operators. So the way the processor evaluates this expression is the arithmetic operators are executed first, then the relational operators, and lastly, the Boolean operator. So the processor, the first thing it'll do with 5 plus 3 less than 10 and 5 plus 3 equal to 8, it'll evaluate the addition. So 5 plus 3 is 8. So we have the expression 8 less than 10 and 8 equal to 8. Then it'll evaluate the relational operators. So it asks the question, is 8 less than 10? True. Then it asks the question, is 8 equal to 8? True. Lastly, we can apply the Boolean operator. So we have the Boolean values true and true. And with the AND Boolean operator, if both Boolean expressions are true, the results are true. So true and true is true. In this example, we're combining modulo arithmetic with our relational operators and Boolean operators. So we're going to ask the question, is the remainder of 10 divided by 3 equal to 1? Or is the quotient of 10 divided by 2 equal to 2? So we have the expression 10 mod 3 equals 1, or 10 div 2 equals 2. So the first thing that happens is we're going to evaluate 10 mod 3, which is equal to 1. Then we're going to evaluate 10 div 2, which is equal to 5. Then we ask the question, is 1 equal to 1? That's true. And then we ask the question, is 5 equal to 2? Well, that's false. So we have true or false. And so when we evaluate true or false, we know that with the OR operator, either operand needs to be true in order for the entire expression to be true. So we have true or false, which is true. In this example, you'll notice that Python gives us some flexibility in how we write our Boolean expressions. In this example, we're going to ask the question, is 10 cubed between 500 and 1000 inclusively? So if we look at the print statement, 500 less than 10 cubed less than 1000. And because we said inclusively, we're using less than or equal to. So the way this expression is evaluated, the first thing that happens is we evaluate 10 cubed, which is 1000. So then we can ask the relational operator expressions, is 500 less than 1000? That's true. Then we can ask the question, is 1000 less than or equal to 1000? That's true. So we have true and true. So the entire expression is true. So the question is 10 cubed between 500 and 1000 inclusively, and the answer to that question is yes, it is true. Let's consider an example of the not Boolean operator. In this example, we're going to ask the question, is 1000 less than or equal to 1000, but not greater than or equal to 500? So the expression is not 10 cubed greater than or equal to 500 and 10 cubed less than or equal to 1000. So again, the first operators that are evaluated are the arithmetic operators. So we evaluate 10 cubed to be 1000. So now we have the expression not 1000 greater than or equal to 500 and 1000 less than or equal to 1000. Next, the relational operators are evaluated. So we have 1000 greater than or equal to 500 is true, and we have 1000 less than or equal to 1000 is true. So now we have the expression not true and true. The next operator that's evaluated is the not operator. In the Boolean operators, not has higher precedence over and. So Boolean Boolean operators are evaluated in the order of not, and then or. So the next thing that's evaluated is the not. So we have not true is evaluated to false. That gives us the expression false and true. And we know with an and operator, both have to be true in order for it to be true. So we have false and true is false. In the previous example, I mentioned that the not operator has higher precedence over the or operator. So the order of operation or of evaluation of the Boolean operators are not, and then or, in that order. So if you want to change the order in which these Boolean operators are evaluated, you can use parentheses. So in this example, I show how you can evaluate an expression using or and then not the entire expression. So in this example, we have not, and then we have the entire expression 10 cubed greater than or equal to 500, or 10 cubed less than or equal to 1,000.